Hi, welcome to the Lux channel. So often I mentioned in many episodes whenever I discuss about network software development, I mentioned saying that people who do the network software development, they lack the real hands-on and knowledge in certain areas of networking, and sometimes it can be basic, sometimes it can be some kind of advanced topics and things like that, versus people who work as network admins. They have extensive hands-on, they do configure the things every day, they see the real deployment, and they have very good hands-on, but unfortunately they lack any sort of scripting and programming knowledge. And sometimes they may be good at scripting, but they still try to cope up with their programming concepts. Anyway, their career is so and so that they need to have very good hands-on with respect to configuring devices, but when it comes about automation, to an extent they can manage to do so, and as they gain experience they can learn and they can manage the things. So here is the situation. I get this question from some of my students, especially who are into network software development. They ask, I got some couple of routes in my Linux system, and sometimes they ask about an individual system, sometimes they may ask about a Linux system configured as a router and things like that. So when I have such multiple interfaces, sometimes these interfaces are connected to the same internet, and how that preference happens, how it chooses a specific interface, and how it routes those packets and stuff like that. So this is where something I thought, let me introduce a concept called administrative distance. Again, I'm saying this is not a video I'm shooting for people who are doing CCNA or something, because this is something mundane level they learn. So this is something very basic concept if you are a network admin. So this is not a video for somebody of that domain. This is a video for network software developers, because this is something very vital, very basic, but unfortunately the domain what you are working, you lack this knowledge. So it is good to understand the same, so that you get that clear-cut idea about what is an administrative distance, and based on this common sense and based on this knowledge, you can correlate how these packets will get treated and how they get routed in a network appliance, or else even a standalone Linux system or some Linux server. So before discussing the same, I would like to give a quick example. In this laptop, usually this laptop, you can see here, this is the route table. So this laptop is unique versus this desktop system, because the desktop system have only one interface port or Ethernet port. So it has only one interface connected to the internet, versus this laptop has wired network as well as wireless network. So if I shut down this UPS, this is connected to the switch, and the switch is connected to this this PC is connected to the switch, and the switch is connected to the Wi-Fi router. But when I shut down this UPS alone, my Xiaomi wireless router can give that can provide that wireless connectivity. So this laptop will get connected to the same. So whenever I turn on this UPS, automatically this gets both Wi-Fi connection as well as a wired connection. So in that case, it can take anything as a preference, and then it can access the internet. So you can see here, this is the routing table, and if I do ifconfig, let me take a screenshot because I'm not capturing the video capture in the same. So if I show to you, you can see here it has two subnets. So both are the same subnet. You can see 192.168.0. So both are essentially connected to the same Wi-Fi router, but one is through wired, one is through wireless. So it again depends on what basis it chooses a specific connection to access internet. So before even getting to the same, it is good to understand what an administrative distance is. So let me just lock the screen, and let me just close this lid. So if you go to wiki and search about administrative distance, you can see here administrative distance. Once again, I'm saying this is not a video meant for people who are doing CCNA or else any network admins. This is meant for people who are doing software development but they are really confused about certain basics. So this is something where when I give an example, I can touch certain areas in kernel and other stuff, so that you can get that bigger picture, just not about some vague idea or something. So if you come and search about administrative distance, I can give you another tip. You can do administrative distance CCNA. Once you type it, you can get some ton of information about the same, because this is a very mundane stuff any CCNA student will learn. So having said that, CCNA is very much targeted for hardcore network admins, because at the end of the day, at some point of time, they may need to configure Cisco devices. So it's a very specific core structure from Cisco, so that they get that prior knowledge how to configure Cisco devices. At the same time, they also know certain network basics. But if you are a full-time network software programmer, you don't need to go do any CCNA certification. But having said so, I have done a certification because long time I thought maybe I be a full-time network admin, and then again I decided that I get into programming in full time, because I am good in programming since my college days. Since there is some kind of issue in job market, I thought let me become a network admin and then get into that domain. But again I switched back. I've been all the time a full time researcher at the same time into network software development. So if you Google about the same, if you get into Wikipedia, you can get extensive documentation about the same. So if you scroll down, this table carries the main significance. As you can see here, this table has this administrative distance numbers. So when you think about network routers, they can route through any dynamic routing protocols. Let us not get much in depth. Let us take a Linux system as an example. So if you do a route command, whatever you are getting this output is sort of statically configured routing table. It is generated, and hope you guys know the networking in a Linux system is taken care by network manager application. If you do sudo dpkg --list grep network capital M, I'm not giving the full word. You can see here it is network manager. So even you can do apt update network or apt install network. You can see here. So such a tool exists. So this is what actually takes care of the entire stuff. So coming back to the same, it's a sort of a job of network manager. At the same time, when you configure these devices, even through ifconfig and other stuff, the route table is created, and in case if you need to change, if you need to add entries, remove entries, you can do the same. Whenever you do configure a Linux system as a routing appliance and stuff like that. So as the way you do, that routing table is generated. But if you think about dedicated Cisco router or Juniper router or something like that, you may have extensive routing table, because it's just not these static routes. It can have even dynamic routes, and you can even do dynamic routing in a Linux system with ZebOS or Quagga or Zebra. So it is from IP Infusion, and when you configure the same, even you can do dynamic routing. So when you do dynamic routing, each dynamic routing is quite different. Some are meant for a specific group of devices. Some are meant to connect two different group of routing nodes and stuff like that. So you have like EGP, and you have that BGP, external, internal, and stuff like that. So based on that specific routing strategy, the administrative distance is assigned, So whenever you have two devices connected next to each other, the administrative distance is 1. So what essentially it tells is, suppose if you have redundant routing tables or redundant routing table entries, not tables, routing table. In the routing table you have redundant entries. So whenever you have redundant entries to the same path, let's take example like this. Let's pretend as if there is another entry like that. So whenever you have such redundant entries, finally each entry says that this is reachable through what and who have created such an entry. So there is where the administrative distance is mentioned. Say we can even do image search and administrative Cisco route table. Since I don't have a Cisco device, we can do some kind of a search, Cisco routing table. Yeah, you can see here, these are various screenshots, and let me see. Yeah, it looks somewhat like this if in a Cisco device. Let me see which. Yeah, you can see here show IP route. So that is what is the command sh IP route. So when you do that, it shows this routing table entries, and here it denotes R for RIP and C for directly connected and stuff like that. So this says, or this intimates what could be its administrative distance. So this is what it signifies. So whenever you have any redundant entries, you have duplicate entries, but whenever this thing changes, then you need to go here and check which has the least number. So whenever it dynamically routes such packets, what it does is the least amount of administrative distance carries the most importance. So if you have redundant entries, then it is going to pick the one which has the least number, and then through that strategy it is going to route the packets and whichever port it is connected and stuff like that. So this is what essentially happens. So this is quite needed when you have a huge web of routers interconnected in a sort of mesh like configuration, so that if something is congested or something gets broken, then it is going to find some alternate path, and it is going to adjust, and it is going to come out of that situation. It is somewhat called as convergence and stuff like that. So I'm not getting that right technical term. I believe it is called as convergence or something like that. So whenever such thing happens, so you need such redundant entries so that it will have some alternate path. So let us take some example like this. Yeah, you can see here this configuration have these three routers. You can assume whenever you send packets from here to here, they can go through this way, they can go through this way, they can even go through this way. So this is so because this kind of redundant configuration enables a fail-safe approach, so that if something goes wrong, it can take some alternate path, and by the time it takes that alternate path, maybe its number of hops or more, means interconnected routers in between those two nodes. I'm kind of explaining this quite slow because these are various technical terms you may never heard of, so that is why I'm doing the same. If you're a network admin, this is quite easy to grasp, but I'm just assuming that people who watches this video are all network software developers, so that they can get accustomed with this terminology. So whenever you connect the routers in between, you have this router to this router, and intermediate, how many routers are there, are called hops. So the more hops, you will get more latency and stuff like that. So, and also the weight for that routing table entry. So it all finally boils down to the same, which is the reason you may have redundant entries for the same route, and based on that administrative distance, the packets will get processed and it will be sent across to that specific port. So you may have an entry from this subnet to this subnet, but to reach through this wire, it has to go to this port, versus if it is supposed to reach from here to here, then it has to choose this port. So this is what it is, just not redundant entries. It is going to be redundant entries of same subnet but to a different through a different port. So if you do again route command, you may clear route. So you may have another entry 192.168.0.0 but through a different port, like what you have seen in this laptop's routing table. So one is a wired Ethernet port, other one is a wireless Ethernet port. So the port changes. So this is what even happens in a a router as well. So this is the thing which decides how the packets are to be processed, and the administrative distance is quite an important stuff. You can see here, based on the routing table strategy you use, the administrative distance changes. The more complicated strategy you use, the more you try to connect with exterior gateway protocols and stuff like that. You have such stuff. What is happening is, so the more you connect these networks through external routing protocols, what happens is it has to go through various hops, and this is naturally going to be a higher administrative distance versus something like you connect it directly, and those kind of static routes will carry more weightage, and its administrative distance is naturally less, because the first preference is something like a static route, because you are manually configuring for some reason, and then the other routing entries have been dynamically generated. You should understand, in a routing table of a real router, whenever you use a dynamic routing protocols, the main objective is it itself does automatically, and it searches and it finds its neighbors, and then it generates this table dynamically. Whenever it is not able to reach any specific subnet or something like that, then it is going to remove that entry and stuff like that. So this is the reason we need to use dynamic routing protocols. So in such a scenario, if you are overriding with a static routing table entry, then it carries more weightage, means less administrative distance versus something which machine itself generates. So that's what it signifies. And before I conclude, I would like to even introduce you guys to one more stuff, so that it also gives you some kind of an idea. So types of dynamic routing protocols. This again, somewhere it correlates to this administrative distance. So let us take a simple example. Yeah, you can see here there are various dynamic routing protocols. Some are interior, some are exterior, and you have this distance vector protocols. When you start learning CCNA, they start with RIP, and then they get to those other advanced and complex routing protocols. So that is the reason the administrative distance, if you see a table like this, from here, if you see here, these are external or exterior gateway protocols. Same way, if you see here, you have more administrative distance for exterior gateway protocol like EGP versus something like RIP and other stuff. So this is where it kind of correlates. So I don't want to go much in depth, but having said so, if you are into network software development, and if you have any sort of confusion, you have some kind of redundant routing table entries, and you need to guess in what basis it picks a specific port and how it sends the packets out to the same subnet, but you have multiple ports pointing to the same subnet, then you need to understand a logic like this, and based on that it has that preference. And if you want to overrule, if you want to change something, then you need to change the routing table, and you need to first, even before changing, you need to understand that such a thing exist. And if you are further curious about the dynamic routing protocols versus something like a static entry or static routing, again you can read about the same. There are multiple ways to proceed this subject. I don't want to go much in depth, because it may not be that often required. It again depends if you are working in something like datacom technology and other stuff, maybe it is required. But if you are working on network applications, and even if you are working in some kind of network parsers or something in kernel layer, maybe it is not required. So in general, if you are curious, you can go through certain topics maybe you must have never heard. In that case you can go through the same. So in general, static, as the name says, you do manually versus dynamic routing protocols. It sends the packets out and it discovers what could be its neighbors, and then it gets the information, and based on the information it knows that how it can reach those other network hops and the subnets, and based on that it creates and maintains this routing table dynamically. So you have that sort of comparison of the same over here. So with this I would like to conclude this video. Hope you guys loved watching the same. In case if you have anything to discuss, be in touch via mail. Thanks a lot for joining me. Take care. Have a nice day. Bye bye.